Oh, g'day guys, Mr. Bennett here. In today's video on Coulombs law, I'm hoping I'm not going to confuse you too much, alright? But it's something that you need to do because I'm going to certainly ask you one of these sort of questions in your test. You need to know how to do this. Now, what you're going to be looking at here is a ratio type scenario, and it's to do with, obviously, what happens if you change either the size of the charge or you change the distance between the two charges. Right, so that's the sort of thing that we're going to be looking at over here. Now, in this example here, literally, if you remember that video I showed you from Paul Hewer on what happens when you change the distance to the force, and it's a proportionality thing that we're looking at. It's called the inverse squared law. Obviously, if you double the distance, you make the force a quarter of the force. All right, a quarter as strong. If you halve the distance, then you'd make it 4 times as strong. All right, so it's about getting your head around this. Quite often, I think you'll know what the answer is, but it's a little bit tricky to show it mathematically how you're going to do that. So in this particular example, when we've got something which is 12 centimeters apart, all right, Q1 and Q2, we don't know what they are, and we don't need to know what they are. We know that the force is 5 by 10 to the minus 5 newtons. Right? We know that the second force is in fact equal to 2 by 10 to the minus 4 newtons. And so therefore, if we equate that to the same units, that's like 20 times 10 to the 5. In other words, force 2 is 4 times as strong as force number 1. Right? So what sort of distance is the particular two charges apart in force 2? Now, for this we know, if we understand our formula, for it to be stronger, we know the two charges have to be closer together. And we know the inverse squared law means that if we want the charge to be 4 times, then it has to be a half of the original. Alright? And the way this works is, if I have radius 2 is a half of radius number 1, when I square that, what I get is 1 over, not 2 squared, 2, but I get 1 over 4. Okay, because you're squaring the 1, you're squaring the 2, and you're also squaring the 1 squared. Now, when you divide by a fraction, what we do is we invert in times. So therefore, that means that that's going to be, force number 2 is going to be 4 times whatever force number 1 is, which is 1 over r squared. Got the idea? So that's the thinking behind it. Now, here's another way of doing that same question. If we know that this is here is at 12, okay, so we don't know what Q1 and Q2 are, we know all these things over here. So what we do know, we put all our constant value in, we put our radius in over here, and we put our force in. We rearrange that, bring it up to the top, bring it to the bottom. We know that Q1 and Q2 is in fact equal to 8 by 10 to the minus 17 coulombs. Well, that would be coulomb squared, I suppose. That's what we know that is, don't we? In the second example for force 2, we know that Q1 and Q2 is that, and we know that the radius over here is going to be 4 centimeters. So therefore, we can work out what the force is over here. Alright, so we know the initial effect and the after effect. For this particular situation, if it's at 12 centimeters for force 1, that's that. If it's at 4 centimeters for force 2, now that's 45 by 10 to the 5. So therefore, it's going to be 9 times as great, isn't it? Okay, so radius 1 is a third of radius number 2. So therefore, radius 2 is it's 3 times radius 2. So radius 2 is a third of radius 1. So when you would square that, that would become 1 over 9, or 9 times as great. Hopefully that sort of makes sense. Let's look at another example of that to show you the mathematics from that. So obviously force number 1 is 1 over r1 squared. So force 2 we know is 9 times force number 1, don't we? We know it's 1 over r1. So that's what it's going to be. So if you understand that concept about proportionality, then you can actually do that. Alright, so force 2 is 1 over r2 squared, which is a third of r1 squared. 1 over 9, so it's going to be 9 times force number 1. Alright? So if we're looking at radius 1, radius 2, so radius 1 is going to be 12 centimetres, radius 2 is going to be 6. So we could say radius 2 is a half of radius number 1. So force 2 is going to be a half of radius 1 squared, or 4 times radius 1. Alright, in this situation over here, alright, just another example, if we have 12 in that, so we could say radius 2 is 3 times radius number 1. Alright, so therefore when we do that, 3r1 squared, so that's going to be 1 over 9 r1 squared. So therefore that's going to be 1/9 of the force. So it gives you the idea of, obviously if you're bringing it closer, it's going to get bigger. If you're bringing it further away, it's going to get weaker. And it doesn't get weaker by just the distance, it gets weaker by the distance squared. Hopefully this makes sense. I anticipate you're probably going to find this the most challenging part of Coulombs law. And so you need to work in it to get your head around it, and you'll need to keep asking some help from either your classmates or from me to work your way through that. Alright? So good luck with them, and you might want to watch this video again, I think, in terms of looking at the examples, and I've also included this particular Word document for you to have a look at as well.